Hi everyone, welcome to My Max Academy. In this session, we will continue on the chapter Real Numbers from 10th standard CBSE Mathematics. We'll continue from theorem 1.1 in page number 3 in your textbook, which is Euclid's division lemma. Now, what is Euclid's division lemma? So it says that given two positive integers, given positive integers a and b, there exists unique integers. There exist unique integers q and r such that q and r satisfying the condition, below condition, satisfying a equal to bq plus r and 0 less than or equal to r less than b. This is what is Euclid's division lemma. So what it says is, given positive integers a and b. So if you are given two positive integers a and b, then there exist unique integers, two more, q and r, such that your a can be expressed as b into q plus r, where 0 is less than or equal to r less than b. And so what it means, if you read the statement, it may be a little confusing. What is a, what is b, what is q, what is r? What is this condition? So I'll give you some example, then you will be able to understand this Euclid's division lemma or this theorem 1.1 in page number 3 of your textbook. Now suppose, let's take an example. Suppose if I have two numbers, suppose 23 and 7 are two numbers. 23 and 7 are two numbers. Like this, you take it as two numbers a and b. So a is 23, b is 7. You call this as a, this as b. So a is 23, b is 7. Then I can write my a as, my 23 as a equal to b is 7 into some other integer. I can write as 7 into 3 plus 2. How can I write 23 as 7 into 3 plus 2? So 7 into 3 is 21. 21 plus 2 is 23. So which means what it says is, right? So what it says is, so this is a equal to b q plus r. So the a is 23, your b is 7, your q is 3, and your r is 2. But how did I find 3 and 2? Right? How did I find 3 and 2? And also the 2 that you are writing, that should be 0 less than or equal to 2 less than b. B is what? 7. The final number should be between 0 and 7. It includes 0, but it does not include 7, and which is also satisfied because your r here is 2, and 2 is between 0 and 7. It is less than 7, but 0 is less than or equal to 2, and 2 is less than 7. So this condition is also satisfied. Clear? So how did I find this? So how did I find this is, if you divide, you will get the answer. If you divide the bigger, you put the bigger number and the smaller number out. Right? So 7, you do the normal division. 3 times 21, the remainder 2. So this is your a, this is your b, this is your q, and this is your r. Clear? So this is your a, this is your b, b is 7. Your a is 23, b is 7. These two are the given numbers, a and b. How did I find q and r? You just need to divide and write the quotient here and the remainder here. Write the quotient here and remainder here. So this is called as Euclid's division lemma. Suppose let's take one more problem. Suppose if I take two numbers, 13 and 77. Right? This is one example. This is one first example. Second example that I am giving is, suppose there are two numbers 13 and 77. Right? Now we have got two positive integers. Now we will always take the greater number as a. 77 is greater, you take that as a, and this is b. Right? So our a is, don't take the first number as a, second number as b always. Here also I took first number a, second number b, because a was greater. So here we will take the greater number as A. So A equal to 77 and B equal to, take the smaller number as B. Now let's divide. Let's divide 77 by 13. Right? How many times go? 13 5s are 65, remainder 12. Right? So which means my A, which is 77, can be written as B. This is B. B into Q. This is quotient, this is remainder. B into Q. 13 into 5. B into Q plus R. R is 12. And 0 less than or equal to R. R is 12 less than 13. B is 13. So which means I can write my 77 as 13 into 5 plus 12. I can also write in some other form. I can also write 77 as 13 into 4 plus 25. 13 into 4 is 52. This is 25. So 52 plus 25 I get 77. But this number, this R should be less than your B. So this value should be less than 13. Here it is 25. So I cannot write like this. Clear? So whatever remainder that comes, that remainder should be less than the divisor. Clear? So which means this way we cannot write. So this is the only way we can write 77. 77 can be expressed in only this way. We cannot write it in any other way. 77 equal to 13 into 5 plus 12 only. You cannot write 77 equal to 13 into something plus something satisfying this condition. So both have to be satisfied. These both have to be satisfied. And your remainder should be always less than the divisor. Your R should be always less than the B. Here 13 is B. A is 77, B is 13, 5 is Q, R is 12. Right? So this is what is Euclid's division lemma, and we will use these to find. There's one more called Euclid's division algorithm, which is in the next page, page number 4. Right? That we use to find the HCF between two numbers. So before we move on to this, before we move on to the Euclid's division algorithm, which is the next page, right? So I will erase this. So any two number can be expressed like this. Fine. So now let's go to I will give one more example on this. I'll give one more example on this. Suppose third example is, suppose you have number 70 and 14. 70 and 14. So 70 is the bigger number. You take this as A. So 70 can be written as 14 into 5 plus 0. It can be 0 also. So this is 0 less than or equal to 0 less than B. B is 14. Right? If you divide 70 by 14, 14 5s are 70. Remainder 0. So this is your A, B is 14, Q is 5, R is 0. So your R can be 0. 0 less than or equal to 0 is true. But it should be less than 14. 14 is the number, that is B. So you can have 0 also. That is why I wrote this example. Anyway, so I hope you are clear with Euclid's division lemma. Now we will go with Euclid's division algorithm. So before we go to Euclid's division algorithm, let's try to understand what is HCF. What is HCF? We all know the expansion for HCF, right? Highest common factor. HCF means highest common factor. So which is called as HCF. That's why it's called as HCF. Highest common, I'll put capital letters here, highest common factor. Highest common factor is called as HCF. So what does it mean? What does the highest common factor means? You will have studied in your earlier classes and you would have found many HCF, LCM also, right? So what is HCF? So which means, suppose I will take one example and then explain what is HCF. Then we will go to Euclid's division algorithm that is used to find the HCF between two numbers. Euclid's division algorithm is used to find the highest common factors between two numbers. So before we go to that to find the HCF, we will understand what is HCF. Suppose if I have two numbers, suppose if I have 24 and suppose if I have 36, 24 and 36, or I will take some other number, 24 and suppose if I take 30, 24 and 30. Now the question here is, if you want to find HCF between these two numbers, HCF between these two numbers, which means HCF means the highest common factor, which means the highest number that will divide both. What is the highest number that will divide both these two numbers? Which is the number that will divide both? 6. The number is 6, because the number 6 is the highest number that will divide both 24 and 30. You cannot have any number more than 6 which will divide both. For example, 8 divides 24, but 8 will not divide 30. Right? If you try to go any other number, right, no number will divide both, which is greater than 6. So 6 is the greatest number, but below 6 we have many numbers. See, both are divided by 2 also. Right? 2 divides both of them. Number 2 divides both of them. Even 3 divides both of them. Both this number and this number are divided by 3. They are divided by 2. So if you write all the numbers which divide both the numbers exactly, among this, which is the highest? 6 is the highest number that divides both. So this 6 is called as the highest HCF between 24, 30. We write like this. HCF of 24, 30 is 6. Why? Because 6 is the highest number that divides both 24 and 30. Highest number that divides both the numbers. That's why. So it's a factor. 6 is a factor of 24, which means 6 divides 24. 6 is a factor of 30 because 6 divides 30 exactly. So which is the highest common factor? 6. Of all the factors, see, 2 is a factor. For 24 and 30, 2 is a factor. The factors are 2 because 2 divides both. 3 is also a factor because 3 divides both exactly. Then 6 is also a factor. 4 doesn't come because 4 doesn't divides this but doesn't divide this. Next number is 5. 5 divides this but 5 doesn't divide this. But 6 is the next number which divides both. And after 6, can I write any other number which will divide both? No. So among these factors, these are the factors. 2 is a factor of both. 3 is also a factor of both. 6 is also a factor of both. Among all these factors, which is the greatest factor? Highest common factor? 6. The highest common. And factor of common factor means factor of both. And 6 is the factor of both, and that is the highest number among these. 2 is also a factor of both. 3 is also a factor of both. 6 is also a factor of both. Among those, which is the highest common factor? 6. So that is called as HCF. So this we will use Euclid's division algorithm to find the HCF between two numbers. Right? If you want, I will give you one more number. So suppose if you want to find the highest common factor between 56 and suppose let's take 70, 77, 72. 72. Now if you need to find what is the highest number that will divide both. Highest common factor means a factor which is common to both, but that should be the highest factor. So if you see these two, right, 8 is the answer, because 8 is the greatest number that will divide both. After 8 we cannot have anything that will divide both. We cannot have any number greater than 8, but that will divide both. 8 divides 56 because 8 sevens are 56, 8 nines are 72. The 8 is the highest common factor of 56 and 72. You cannot find any number that is greater than 8 that will divide both 56 and 72 exactly. We cannot find. That's why it's called as HCF, highest common factor. Right? So now we will go to the Euclid's division. We'll go to Euclid's division algorithm. Euclid's division algorithm. So we will use this algorithm. Algorithm is nothing but what? It's an algorithm is nothing but a series of well-defined steps which gives a procedure for solving a type of a problem. It's also the definition is given in page number 4 top. Algorithm is a series of well-defined steps. It's a series of well-defined steps that gives us a procedure to solve a problem. Or you can, to put it very simple, is the series of steps which gives the procedure to solve a problem, which gives an idea to solve a problem, or which gives procedure to solve a problem. That is called as algorithm. Now we will use this Euclid's division algorithm there is one set of steps that we should follow to find the HCF between two numbers, right? So the algorithm, if you do the problem, then you will understand the algorithm. So we'll do example 1. We will do example 1 in page number 5. Page number 5 in your textbook. We'll do example 1 in page number 5. So what it says is, use Euclid's algorithm. Use Euclid's algorithm to find the HCF of, HCF means highest common factor of the two numbers which are 12576 and 4052. So we need to find the highest common factor of these two numbers using Euclid's division algorithm. So what we should do in the first step is, we need to apply our Euclid's division lemma for these two numbers. What is the first step? First step is, so I will say step 1. Yes, we will try to apply the Euclid's division lemma that we studied. A is equal to BQ plus R. That for this. So we will take, first step is, we will take A, the bigger number as A, 12576, and the next number as B, 4052. The smaller number as B. Always take the bigger number as A and the smaller number as B. Then let's apply our Euclid's division lemma, right? So by Euclid's division lemma, I write it as EDL. Right? What we have? We have A is equal to BQ plus R, where 0 less than or equal to R less than B. Right? Which means your A can be expressed like this. Right? So which means, so to get this, A is 12576 equal to B. B is 4052. Then Q we don't know, we need to find, and R also we should find. How do we find Q and R? To substitute here, we will divide this. We'll divide 12576. If you divide by 4052, right? We'll do a normal division. So we do normal division, then you try 3 times. 3 2s are 6, 3 5s are 15, 1 4 3s are 12. Now if you subtract this, 0, 2, 5 minus 1, 4. So now this is your Q, this is your R. So my Q is 3, 4052 into 3 plus R is 420, and that should be less than this number. If the R should be less than the divisor. So 40420. Right? And R satisfies the other condition, which we don't have to worry about this condition here, because it's just R is, if you want you can keep writing this condition also. But for finding the HCF, we will focus on only this. But you should always make sure that your R is not greater than this. This should be always less than this. And obviously when you divide two numbers, the remainder will be always less than that divisor. Then we have to check whether the remainder, second step is we have to check whether the remainder is 0. Right? The second step is we need to check whether if the remainder is 0. Here the remainder is 0. No. This is the remainder. R should be 0. When R is 0, we have to stop the problem. Then we will get the HCF. So till R is 0, we have to continue to do this. So now here R is 0. No. When R is not 0, then we should go to the next step, that is step 2. We will take your A will become this number 4052. The B of the previous one will become A, right? And your B will be equal to the remainder R 420. You able to follow this, right? So here what will happen? Your A will become, your previous B will become A, new A. Right? So this 4052, this will become A and this will be treated as B for the next step. Then again we should write A is equal to BQ plus R. We have to take these two numbers and express this 4052 equal to B is 420 into Q plus R. To find that we have to divide these two. So divide this number. So 4052. If you divide this number by 420. So this is your A. This is your B. How did I get this A? You have to take this number. This is your B. So this B will become A and your remainder will become B. your R will become B. Your B will become new A. The previous B will become your new A, and your R in this step, previous step, will become B in the next step. Clear? Now we should again divide these two. 402. So if you try 9 times, right? 9 zeros are 0, 9 twos are 18, 1, 36, 37. Fine. So now you subtract 2 minus 0, 2, 15 minus 8 is 7, then this is 2. You get 272. That is your R. So this you are writing it as B into Q. Q is 9 now, into 9 that we have got. Then R is 272 plus 272. So you should always make sure that this value is less than this value. If it is greater, then you need to go to the next number. You need to increase the quotient. So obviously your R should be, the remainder should be always less than the divisor. Now again we should check whether this is the R, whether this R is equal to 0. This is not equal to 0. So R is not equal to 0. When R is not equal to 0, we should go to the next step 3. We should take A, this is by Euclid's division lemma. By Euclid's division lemma, I can write this as BQ plus R. Now again the third step, I will take my A as this one, the B, 420. A will be the, in this step A will be equal to the B of the previous step, and then your B will be the B of the current step, step 3 will be the R of the previous step. What is R? Remainder 272. So that will become B in the next step, 272. Clear? So your A in this current step is equal to the B of the previous step, and your B of this step will be equal to R of the previous step. R is the remainder. This one, this is R. And we will continue to do like this till you get R equal to 0. The moment this R becomes 0 in any step, you will stop that. And you will stop that. In that case, we will be able to find the HCF. The B will be the HCF. That point, what is B? When R becomes 0, if this is 0, this will be the HCF. The B will become the HCF. This is B. So we will continue to do, because here R is not equal to 0. So we will continue to apply. So then by Euclid's EDL, Euclid's division lemma, A equal to, so 420 can be written as B into what? That we have to divide. So divide again. 420, 272. 1 times it goes, 272. Now if I subtract, right? 10 minus 2 is 8. Then 11. 11 minus 7 is 4. 3 minus 2 is 1. So you get 148. So this is 272 into 1 plus 148. Now again we have to check. This is the R. R is not equal to 0. Again we should go to the next step. Step 4. We should keep on doing this step. So step 4, what is my A? My A is equal to the B. B of the previous step. This is 272. And my R will become B. B is equal to 148. Now again apply Euclid's division lemma between these two. By Euclid's division lemma, what we have? A equal to, which means 272 equal to B into what? To find that you are divide 272 by 148. Right? So can I erase this? Or I will do here. I will do down. Fine. So I will divide 272. Fine. I am going to divide 272 with 148. So 148 ones are 148. Right. Now if you subtract 12 minus 8 is 4. 6 minus 4 is 2. 2 minus 1 is 1. So you get 148 into 1. So quotient is 1. Plus remainder. Remainder is 124. 124. Clear? But again what we observe? The R is not equal to 0. So we should again continue. Right? If we again continue, we'll go to step 5. Step 5, what happens? My A becomes B, 148. And my B will become 124. Now again Euclid's division lemma between these two. So by Euclid's division lemma, A equal to B. A equal to this one. A equal to BQ plus R. A equal to B into, what is that Q? We have to divide again. 124, 148 should be divided by 124. So if I do that here, 148, 124, 1 times it goes 124, remainder is 24. Right? Now again what happens? I can write my 148 as 124 into 1 plus 24. 24. Now again the remainder is not equal to 0. So we have to go to the next step, which is step 6. Again we have to repeat the step. So step 6. Clear? So what is our step 6? Step 6 is we have to take your A as the B, which is 124, and your new B is equal to the remainder 24. Now again apply Euclid's division lemma. So by Euclid's division lemma, what is the Euclid division lemma? A equal to BQ plus R. So I am not writing every time the same thing. Hope you can understand this. We are applying this. I am writing it here. A is 124 plus B is 24. Sorry, A equal to B. B is 24 into Q. Q we have to find. What is quotient? What is remainder? So that we have to divide. But again do the division. So I'll do the division here. So if I divide my 124 by 24, right? 5 times it will go 120. Remainder is 4. So I can write 124 as 24 into 5 plus 4. 24 into 5 plus 4. Now again what is the remainder? 4. It is not 0. Again we should apply, we should do again step 7. Step 7 is my A will become this 24 and my B will become this 4. Now again we should write, we have to apply by Euclid's division lemma. My A should be equal to BQ plus R. So A is what? 24 can be written as 4 into what? So if I divide my 24 with 4, I'll get 6 times 24 and the remainder becomes 0. Right now, so I will write this 24 as 4 into 6. 4 into 6 plus 0. Now we should stop here because our remainder became 0. The moment the remainder becomes 0, you have to stop and your HCF will be the B. This one. What will be your HCF? Whatever is the B here and this step. Whenever 0 comes, this is your HCF. The B of that step is your HCF. So therefore, so R equal to 0. Therefore, HCF is what? HCF equal to 4. So the highest common factor between these two numbers is 4. So 4 is the maximum number that will divide both. You can't find any number greater than 4 that will divide these two. Clear? So this is about example 1. Fine. So it may look lengthy, but you just need to do normal division and then put the quotient and remainder here. You just need to keep applying this step. Fine. So we will go to the next problem. Let us this. We'll go to example 2. Fine. So I'll go to example 2 of second one. So example 2. And or what we can do is we can probably do one more sum before we go to the example 2. Shall we do one more sum before we go to the example, or it is there in the exercise? Fine. So okay, so anyways we will do example 2. That's fine. Example 2 is in the textbook, page number 6. Page number 6. Page number 6, example 2 in your textbook. It says that show that every positive even integer is of the form 2q and every positive odd number is of the form 2q plus 1. We have to prove that where q is some integer. We have to show that every positive even number is of the form 2q and every positive odd integer is of the form 2q plus 1. So for that the solution is, so question you can see the book, I am writing the solution. Right? The solution says, solution is we have to take, we will say let A be any positive integer. Now what we have to show, if A is even, we should show that A is equal to some 2q. right? We should show that A is equal to some 2Q if A is even. This is what we have to prove. And A will be 2Q plus 1 if A is odd number, odd positive integer. So this is the question. You have to prove this, right? So we'll start with let A be any positive integer. When A is any positive integer, and we will take B as let B is equal to, you should always take the B as this 2. Whatever you have to prove A as, we have to prove it's a 2Q or 2Q plus 1, then take B as this 2. If you take B as 2, so A is any positive integer and B I am taking it as 2. So then let's apply by Euclid's division lemma, EDL, what we have. I can write A is equal to BQ. A is A here. A we don't know. A is A. B is 2 Q plus R. So here we know only B. We don't know A, Q and R. So we'll write it like this. And where 0 less than or equal to R less than B. B is what? 2. We know only B here. The only value that we know here is B. Fine. So which means, what is this? So A equal to 2Q plus R, where 0 less than or equal to R less than 2 means what? R can be, so R equal to 0 or 1. R can be 0 or 1. It cannot be 2. R should be between 0 and 2, but including 0. Which means R can be 0 or R can be 1. R cannot be 2. Because R should be less than 2. So we have only 2 values for R. What is the meaning of this? R can be 0 or 1. R can be 0 or 1. Now we will, based on the values of R, we need to take different cases. We will take case 1. Case 1 is when R equal to 0. When R equal to 0, what this becomes? You have to write this. So A becomes 2Q plus R. So A becomes 2Q plus 0 because R is 0. Then A is equal to 2Q. When A is equal to 2Q, right? Which means since A is equal to 2Q, 2 into some number where Q is an integer. Q is an integer. Q and R are integer. A is equal to 2Q. Since A is equal to 2Q, therefore A is even positive integer. Even positive integer because A is of the form 2Q. See, any even integer, it will be 2 into something. The moment you get A is equal to 2Q, which means A is an even positive integer. Right? So now, then let's take next case, case 2. Case 2 is we'll take when R equal to 1. We have to take the second case. R equal to 1. When R equal to 1, what happens? My A is equal to 2Q plus R. My A will become 2Q plus 1. Right? But we have proved that here A is an even positive integer whenever A is 2Q. A is equal to 2Q form. Right? Here we get A is equal to 2Q plus 1. Right? And already whenever A is even, it is in this form 2Q. 2 into Q. But here A is 2Q plus 1 because I am putting R as 1. So this means what? This means A is an odd positive number. Because if A has to be even, then it is in this form 2Q. So here it is even, therefore this has to be odd because it is of the form 2Q plus 1. So A is an odd positive integer. Therefore, any even positive integer is of the form 2Q. Is of the form 2Q. Any odd positive integer is of the form 2Q plus 1, where Q is some integer. Where Q is some integer. Where Q is some, this is Q. Q is some integer. Clear? So this ends the proof for the second problem. So when A is an even integer, it is in this form. And whenever A is an odd positive number, it is in this form. A is equal to 2q plus 1 means it has to be odd, because even means it should be in this form. So which means, but A is any positive integer, which means A can be either even or odd. In this case it is even, means in this case it should be odd. Therefore we can write that any even positive integer is of the form 2q and any odd positive integer is of the form 2q plus 1, where q is some integer. Fine. So we will stop the video here. I'll end the session here. You watch my next video for the continuation of this chapter. Thank you.